If you don't mention the EM field, you get an F.
This little thing helped me more than my last therapy session. It's called the Pandy, a lifelike plush toy designed and powered.
I don't care.
When the right path is open,
I'm gonna...
Beautiful.
Alright, so to preface, the normal double slit experiment that I was aware of, and no, I have heard of using light before. Maybe I've even responded to this before in my previous channel, but I haven't responded since I've made this channel. So, you know how it is. You gotta cover it so that it's covered because it's no longer covered because it no longer exists elsewhere from me. So, we gotta get into this. Here's the thing, right? Actually, we will go back to where we left off because she says something I already disagree with, or have issue with. It's important.
Explain that. But there is another wave phenomenon that particles definitely can't mimic, and that's canceling.
Water is just particles.
Out.
One way to think of the last experiment is that it's like we took the hair experiment and then just blocked one path.
We found that at least some of the light ends up in all of these places, including in this spot. If we had blocked the right path instead, we'd have gotten a very similar result. And again, notice that at least some of the light falls on this spot.
Right?
Now let's open both.
So here's the thing, right? Earlier in the video, you already know, and there's a little hint about what's happening with actual water, is that the water will hit an obstacle and it will, for some reason, spread out in this cone shape, okay, heading around the bend. It's interesting that this is what's happening in the double slit experiment also, simply because between the two slits is a barrier. Does it matter if it's a closed off slit or an open slit? I don't think so. So,
Part of the wave does do, but the rest of it bends and spreads out.
So here's the thing. The stringing analogy that she has is basically this, but doubled and flipped. The water or liquid or whatever it is able to light as well, which means light must also be particles. Wow. That's actually kind of cool. Here's the thing, right? If you take this exact same phenomenon of it hits a barrier, and then on the one side it starts to just flow that way, if it's able to flow on the other side as well, you'll get the same ripple, but in the opposite direction. And where these two pressure waves intersect, that's an interference pattern. So that means the part that she talks about here, around 6:30-ish,
that spot. And when the right path is open, some of your particles will reach that spot. But when both of them are open, it's like the particles from the right side and the particles from the left side just happen to cancel each other out in this spot, which just doesn't make sense. But why not? Why can't you just have the particles cancel?
Okay, so again, you can do this at home. In fact, I could do this right now. Put like a little thing in front of some water and watch the waves as they go towards each other and make it a interference pattern. This would prove that light is actually particles. Huh.
Well, because in this spot, they need to cancel. But just a little bit over, the particles coming from the left and from the right should happily coincide. It's like they sometimes choose to cancel and sometimes they choose not.
Yeah. That's... the interference pattern that happens, okay, you have to understand a laser is different than regular light, but we're going to try to ignore that for the first moments of this. Really, this gets down to the brass tacks of the whole reaction. I don't need to watch the whole thing. I'm here. We're at the important part. So here's the thing. The interference pattern is each ripple that goes through makes different push on both sides interactions. As you can see, it changes direction a bunch. Yeah, that's because you're getting different amounts of push from both sides interacting as they coalesce, and you end up with
Two. So, I'm sorry, Nishan, but particles like yours really aren't good enough to explain how you could ever get cancelling.
interference pattern.
But then, how do waves manage to explain the double slit experiment?
Let's imagine a wave is coming out of the laser. On the right side, the wave
Now, here's
encounters
the thing,
hair.
right? Waves is a completely separate idea to how, like, when you normally have the water thing, it's interesting. You do have that, oh, we're going to block it on one side, block it on the other side. You didn't show the, why wouldn't you show the experiment of you just blocking it with, like, your finger or something? Or the handle of a butter knife or whatever. Flow the water through. And then you end up with the interference pattern that you normally would expect. I mean, this happens with water. And like anyone else would say, water is just a bunch of particles that's moving. So if the interference pattern happens with particles, the fact that she's saying it doesn't happen with particles is ignorant of reality. Like, you're missing just some key bits of easily testable experiments, or you're omitting them, trying to push the idea that light is a wave. I'm usually on here being bothered about electrons and stuff, and I mention how electrons definitely are particles, so the fact that they work the way that they do, you understand that electrons move with electromagnetic fields, they orbit atoms, right? The electromagnetic field is the thing that connects the electrons to protons, as well as other stuff like magnets and whatever. So, but the magnetic field isn't the electron itself, it's another thing. It's this thing, it's an aura that's surrounding the electrons. But it's the influence of the electrons in the electromagnetic field. Understand that the electromagnetic field is not just nearby something, it's everywhere, and it's either excited by nearby molecules or it's not, because there aren't any nearby molecules. So if you have, or electrons, if you have electrons, then the electromagnetic field gets excited and it's able to then do more with it. The more you excite the electrons with an electromagnet, then you're able to have that energy spread out and then affect everything else because it is flowing like that. But it's not, it's a relationship between the energy being put into the motion of the electrons and then how that affects the field itself. But this is talking about light, which is, we understand, almost everyone understands light is wavy. naturally. Light interference patterns is interesting.
And because it's an obstacle, it bends and it spreads out like we discussed before.
Yeah.
On the other side, the exact same thing happens.
It's so... Wait.
Back in our wave pool, the
Okay, that's weird.
black obstruction in the middle now represents the hair. And as you can see, the waves on either side do spread out and they overlap.
Yeah, they overlap. What am I looking at?
I do spread out and they overlap. But something very surprising is happening in that overlap, and you can't really make it out in this precision setup, but it's going to be a lot more clear in the animation.
Yeah.
Where are all these lines coming from?
If that, again, I don't understand why you would say particles can't do this thing when water itself is doing it and it's just a bunch of particles. There's no difference. The interference pattern is there. It's these bands of lines that pretty much everyone witnesses, because it's where all of the waves press up against each other. They make these bits of high pressure and low pressure, and it's those low pressure zones where the electrons would go. Now when it comes to light, how would it actually work? And you would think that the high pressure zones are where the light is going to go. But if it's interfering with itself, then perhaps the electrons would also go in the high pressure zones, and my intuition was wrong. But either way, because you'd think they would go to the points of low pressure, but if the electrons are the thing that is making the... And how does this make me feel about the whole thing? Well, it just proves that it makes it more seem like photons are what light is.
Understand what's going on? Imagine you're on a boat in this spot.
Then the wave coming from the left will have its peak reach you at exactly the same time as the wave coming from the right. Together, they tend to push you up even higher. The troughs also meet you at...
Yeah, you have to understand that you're not the boat. The electrons, the photons, these are the waves. These are the things making the waves. Or the EM field is making the waves. And the light is following. Or the electrons are following.
At the same time, so this spot is just really choppy. But if we instead move our boat to here, then the peak of the right wave hits exactly when the trough of the left wave hits you. The peak tries to move you upward, while the trough tries to pull you down. And so in the end, they cancel out and the boat doesn't really move up or down. So this spot is surprisingly calm. There are these choppy and calm spots all over. And if you map them out, then you get these lines. What's this got to do with the double slit experiment? Well, look at the waves across the wall. You have these alternating parts of choppiness and calmness. That lines up.
Now, here's the interesting thing, right? The reason why I always get stuck on electrons is that when you shine a laser across where this wave pattern starts, it interferes with the waves, but the electrons still go through, proving the electrons are definitely particles. They have mass, they have something to them, so they're not just waves. Or they're not...
Suspiciously well with the pattern of the double slit, where you have alternating spots of light and dark. Thomas Young's hypothesis was, when there's this waving, there's light. And when the waves cancel out, and so there's no waving, there is no light. In other words, the amount of light produced in a spot is proportional to the amount of waving. You know, I've given this explanation to students for years, but I've never taken the whole wave picture very seriously. Like, yes, I knew that to make the right prediction for the double slit, you would have to use waves in your calculation. But I thought they were just that, like just calculation tools. I didn't think that they were real. I mean, like literally in quantum.
Particles behaving like waves, water behaving like waves, light is basically a particle. This isn't evidence towards light being a wave. Although, like, the frequency of light is calculated, measured, understood as part of its function. So it's like there's this interesting dichotomy of like, and when you shine a light through a prism, what's happening to all of those? Well, the different distances that each one of them has traveled towards the edge of the prism changes their total distance and travel until they meet and exit out another section of the prism where they will then have a different amount of travel that goes out. Any prism will do that. You get the rainbow pattern, or you end up with concentrating with lensing, or attenuating or spreading out with the other lensing.
Mechanics, the waves are complex valued. So instead in my head, I thought of the light as a particle when it exited the laser.
The history of our Earth is so different.
A particle when it exited the laser, and then a particle again when it got measured at the wall, but in between it just seemed like there's nothing you could really say about the light besides a bunch of equations. But this next experiment is what changed my mind and made me finally feel that the waves are actually real.
So I've been playing with this for a while and I haven't been able to get this thought out of my mind. There's a beam here that leads to this middle dot. That's clearly where the light for that dot is coming from, right? But what about all these other dots? Like, surely that light is coming from somewhere as well. And it feels like you can almost trace back exactly where that light's from. For this one, if I follow it,
Yeah.
I can go all the way back. And same for these as well.
Yeah.
So it feels like there should be beams kind of coming out here.
That's because the
I
more
got
dense
obsessed with
lasers only have so much light and whatever else. But if you have just the light itself, not the laser beam, which is always more concentrated, the light itself is still going to be able to spread out and do stuff.
This idea that you should be able to see these beams of light if you just use the right method. I tried everything, like doing
Basic
the
fog.
experiment at midnight for maximum contrast, and then filling a box with smoke.
Yeah.
Then I tried filling a tub with water vapor.
Again,
I even
light-
tried submerging my laser.
The thing is, light is not a laser beam. Laser beams are... like I said, very concentrated versus how light is when you get it from a light bulb.
Into Agar. Nothing. In the end, I caved and I bought a smoke machine from a DJ shop. And I also decided to use the proper double slit so that the little bands are more intense. And it worked.
I would love if you actually tried this experiment yourself because it's so easy to do. But I need to warn you about something. Laser pointers are way less safe than you probably think. I bought a bunch of lasers from Amazon that all claim to be under 5 milliwatts. Anything over that limit can permanently burn a hole in your retina. So let's compare these cheap lasers with a proper 5 milliwatt laser.
I think it's Staraparo who talks about lasers, and it's like, yeah, there's all sorts of things to be very much aware about how lasers are either calibrated, how they actually divvy out the energy, and the intensity and everything, it is so possible to get something that's more dangerous than what's on the tin.
To see if they're safe. As you can see, this green one is definitely not okay. In general, green lasers are something I really don't recommend you buy from Amazon. Red laser pointers are better in my experience, especially little ones like this that are advertised as like keychains or cat toys,
Little.
rather than like this type. But yeah, if you're going to be using a laser for presenting or experiments or playing with your cat, just make sure it isn't one that's going to burn someone's eyes out. Anyway, it was worth buying the smoke machine. This experiment looks just magical in real life, and all I've done to capture it is use my phone, nothing fancy. I set the double slit up a few meters away and blocked all the lights and turned on the smoke machine.
Here's the problem, right? My major beef, you literally did the water thing, you end up with the interference pattern of water, you say that particles don't do that, and then you go off on some tangent. I don't know what your conclusion is yet. I'm assuming that you're more leaning towards waves instead of particles, but it is particles, that's the problem. And you're missing the point, possibly.
It became visible. Here you can see that there are beams of
You
light.
better
going
say
through
particles
all
at the end of this
dots in the
video.
double slit pattern.
Where are you
And
getting
to see
that?
it even more clearly, let's turn around and look toward the laser. And now, so many beams become visible. The double slit doesn't split the light up into two beams. It splits
Obviously.
the light into many, many beams.
That's because of interference patterns. It's the exact same thing.
So why was this experiment such a revelation for me? Well, it felt like I was actually seeing the light be a wave for the first time.
Let me show you what I mean with this laser. Here you can see the narrow beam of the laser, but if I put this paper in the way, a wave should spread out. And yeah, that's exactly what the laser does. But to see it more clearly, let's add some smoke. This looks almost unreal. The laser beam is spread out, but only in this one plane, just like we'd predict for a wave. If I remove the paper and put in the double slit instead, you can see the two sides of the beam interfere and cancel out. Again, just like a wave should.
Yeah, like particles
Seeing
do.
this was the first time that I actually felt in my gut that light is somehow wave-like. Up until now, I just thought that the waves of quantum mechanics were abstract, and they're not. They're actually there, and you can see pretty clear evidence of them.
Yeah,
And so
unfortunately
since
you're
then,
missing...
I've started taking the whole wave picture much more seriously. On the other hand, I've become more cautious about imagining light as particles.
You literally did an experiment talking about how, and you showed in part of your video, how the interference pattern can come out of water. This video was 2 years ago. Maybe you have a change of mind or heart or something, a different thought that was less... Okay. I did a quantum eraser experiment. What? That's not the biggest lie about the double slit experiment. Oh wow! So you made a new one. Let's fucking watch that. Shut up.
There is a lie about the double slit experiment that's told by everyone.
Uh-huh.
From famous physicists to YouTubers, and even me, when I used to believe it. The lie is...
You literally made a video about this 2 years ago. What are you going to say now? This is your own information we're talking about, referring to being possibly a lie.
When you shoot electrons at two slits, if you don't watch which way they go...
Now you're talking about electrons. Cool.
...through, they'll act like waves. But if you do watch which way they went, then they act like particles. They go straight through and they end up in two clumps.
Yeah.
This actually contradicts the results of the experiment, and it's completely the wrong lesson to take from the double slit experiment.
No, don't say watching, because watching involves, again, you're using... The only way that you watch or detect Electrons is with a beam going across the thing, which is an interference in the electromagnetic spectrum. It changes how the interference pattern from the EM field is able to emerge. So you end up with particles that naturally work as if they were just shot out of two different slits, because the EM field does go forward first. It hits the two slits, but then it hits this beam that you're facing it, and the waviness part of the EM field is dissipated completely. The electrons go through uninterfered, so they just go through.
But this light has been told so often that it's kind of got a life of its own. The real lesson of this experiment is way more interesting, and I want to tell you about
I
that.
want to hear.
But first, let's find out what the electrons actually do when you observe them. Because it's not this. Imagine that we do have a bunch of particles like this that are going to go through this double slit experiment. You expect to have like two bunches of particles. And actually, these slits are very narrow and very close together.
Extremely
so you
narrow.
Expect a bit of overlap between those two heaps. But here's what would happen for a wave. Okay, so I love this website because it's a wave simulator, and I'll link it in the description. But
Okay.
basically what we're doing here is we have this wall with two narrow slits, and we're going to see what happens when these waves go through.
You know that you
Okay,
did the
so
same thing
what
with,
you're seeing happen here
with water.
is that there are these two waves coming from each
Uh-huh.
of the slits, but when they touch each other, something weird happens. They interact with each other and kind of overlap.
Yeah, it's the same thing where the water was going through, making a wave that then curls in. The other side is curling in on the other side. You see both of them. They interfere with each other. This is a fluid dynamics thing.
And if we let's go further,
Yeah,
these
you end up with the
interference
bands.
patterns always kind of look like this, where there's a very strong bit of wave in the middle, then there's not much, and then there's more wave, and then again there's a blank spot, and then another strong spot, etc.
Yeah.
And as we saw in that simulation, what you'd expect for
You
a
did-
wave is that it hits this back wall in this very funny pattern. There are some spots like this
Yeah.
one where it's very intense, and then there are some spots like this where it's not intense at all. And there are these little bands of, intensity and no intensity. And when you do this experiment with light, that's exactly what you see, which suggests very strongly that light is a wave. In fact, the double slit
It's a fluid.
experiment was the thing that really convinced people that light is a wave after all.
I'm
And
sorry
I've done the double slit
that they
experiment
think
in a couple
that.
of videos before, and I always get a lot of comments being like, this is just classical optics. And that is true. But then they say, therefore it's irrelevant to quantum mechanics. And that I disagree with. And I'll explain why
Very
a
relevant
little
to
bit
quantum
later.
mechanics.
But
What are you
first,
talking? It is
let's
the only
think about
quantum
the same
mechanics.
experiment with electrons. Is it going to turn out more like the particle case or more like the wave one? Well, this is footage from an actual double slit experiment using electrons. So let's see what the answer is.
Yeah.
Well, it's looking very promising for particles because unlike with a wave, the result isn't just sort of smeared out. It's coming in these individual dots. But if we
Yeah.
let the pattern develop, you start to see that it actually isn't in two lumps. It looks much more like the double slit interference pattern for waves. So
Again, this happens with water, which is particles. That's what electrons are. They're also little dipoles. And photons are just really tinier, the most simplest, because they are made of the most little amount of stuff. Dipoles. Fluid dynamics. But, so you get, this video, as far as I'm understanding, again, the more recent one, gets an F for completely missing the point.
something really odd seems to be happening with these electrons. there seems to be some sort of wave associated with the electrons. And the wave spreads out, and just like a water wave or a light wave, it goes through both slits. The only real difference between an electron and a wave that goes through both slits is that the electron still ends up as dots. It isn't smeared out the way that waves usually are.
Okay, hold on. Light is extremely much more small than electrons. When you're sending out a beam of light with a laser pointer or with a light bulb, you're getting extremely fine detail down to the angstrom and whatever. So nanometers and whatever else are covered with tons of light per square nanometer. And with electrons, it's a lot less. Obviously, because electrons are much bigger than a photon. We know this. It's understood. So, you're going to see the dots. That's because that's how they present. Because they big like that.
As dots. It isn't smeared out the way that waves usually are. But this feels wrong, because for something like light, I mean, it's perfectly fine to accept that it's some sort of wave. But for electrons, you know, we're used to thinking of them as little bullets like this, little particles.
Again, we're also talking about water, and water is nothing but particles. So, all of the scenarios are actually particles. You just haven't caught up with reality yet. I'm sorry. That's just how it is. I'm not trying to be mean. I'm just like, you're fanatic a bit about this, and it's not okay. We already proved that waves happen with water.
And a particle couldn't be going through both of these slits at the same time.
No.
That's why it's really natural to think that if electrons really are going through both slits, then maybe let's try and catch them in the act. Let's put two measuring...
You notice that the particles are... First of all, the size of the beam, the size of everything is relevant. You never mention the size of all of the experiments and everything. But it's important to know that there is a discrepancy between one electron being shot and another one by, like, many times the diameter of the electron itself. So it has its own different shooting positions naturally. When you fire the single beams, you end up with a scatter shot of electrons because it's not super accurate to the point of one electron width. It's spread out because it is inaccurate. Therefore, when you shoot it through the double slit, some will end up through one side, some will hit the double slit wall, and some will go through the other side. Are all of them accounted for? I don't think you're going to say. Doesn't matter. But the fact that you know that there is a scatter shot in the beginning of your video, you gotta know, yeah, some are going through this side, some are going through that side.
Devices here and here that will watch both of these slits and will tell you whether the electron actually goes through both slits. The idea is that we want to be able to catch the electrons doing both things at the same time. But
here's the thing. If you're using anything other than an optical camera, you're using a laser beam. And if you're using a laser beam, you're going to interfere with how the EM field can do things in the area.
Measurement in quantum mechanics doesn't work like that. So in quantum mechanics, when you try and measure an object that's in a superposition of two different things, like this electron going through both slits, then you will see a particular result. For example,
They
this
clump up
detector might
into
see
two
an
parts.
electron go by. But now in quantum mechanics, what happens is that measurement changed the electron. Now it's only going through one of these slits, the one you observed. So far, this is all correct. But
the EM field is still going through both slits. The electron, of course, only went through one. I said my piece.
here comes the myth. Many people will tell you that
You're
now
getting
the
an F.
electron has been measured, it becomes a particle. And so this particle
It
will
doesn't.
act like
No, well, okay, they will say that. It never becomes a particle. It was always a particle. You just happen to notice it for some reason more. No, when you have the interference pattern on that part of the video, all of those little dots in the interference pattern, particles. Wow. Doesn't matter if you have where they land in clumps or spread out in interference-based clumps. They always act like a particle. We are never confused about that. You're making up stuff at this point.
any normal particle will sort of end up here. And so you can imagine that if we keep measuring which way every electron goes, then you end up with two piles of electrons. People will draw the results just like this, as two clumps, or at most as two overlapping clumps.
We saw it in the
So
video
before
already.
I ever did these experiments myself, I assumed that this is what happens. But that's not at all the case.
Again, if you're not doing a double slit experiment with equipment that is near to the speed of an electron, how fast is it? Oh, I don't know. 2.2 thousand kilometers per second? Or 2 million meters per second? If you're not as accurate as 1/4,000,000th of a second, you won't be accurate to the point of that's how many electrons or an electron moves 2.22 quadrillion atomic widths per second. If you're not that accurate, you're not going to see it with correct vision or whatever.
Like this?
I wish I had experimental footage of someone actually doing this experiment with electrons to show you that this is not what happens. But
Listen. You want to know how the footage would look? You see this? Imagine there's only 2 bands instead of 5. Right now there are 5 bands of electrons. If you take that and simply imagine that there's only 2 of them, that's the footage. There's particles here, there would be particles there. But there would be more of them in 2 bands than there are all of them spread out. Also, we use a type of gel and whatever else that is like it lights up when the electrons hit them. We're not seeing an actual dot of an electron. Don't fool yourself. We're seeing a reaction the electron makes. Come on.
is this crazy pattern. It doesn't look anything like 2 lumps. This is actually called the single slit interference pattern, and it's still very much wave behavior. Let me show you.
Today we are responding to a comment we got on our YouTube channel.
Still very much
I'm not
wave
gonna
behavior.
focus on
Let me show you.
commercials.
So this is what the interference pattern looked like with the 2 slits here and
Yeah.
here. But what happens if we take that away and instead just have 1 slit? So here I can change this from double slit
Try not
single
to
slit,
touch your monitor.
and let's see what happens.
Wah.
Okay, so it's much less distinct now, but you can still see some funny pattern going on here. So look what happens at this bit where the slit is. You can see that there's like a funny sort of edge effect on both sides. And that edge, these two edges, are what are going to interfere with each other. So the edges of that single slit interfere so that you get this kind of weird interference pattern. It looks quite similar to the double slit one, but just with like less fringes. So there's this bright fringe, and then a dark fringe,
coming in from
and then
both sides.
a much less bright fringe, a dark fringe, etc. The single slit interference pattern
And doing a
looks something
physics
like
with
this.
each other.
But again, when we do this experiment with electrons, not actual waves, what we get is a slightly different pattern. We still get the electrons arriving in individual dots like this, but it's just that the dots are going to be according to this pattern. If you're wondering how this is different from the double slit experiment, remember for that, there were all these little dips inside the bigger single slit pattern.
Yeah.
Like this. So when you're not observing and you let the electrons go through both slits, then you get even more interference. But even when you just allow the electron to...
You're not... The more extreme sin here or error in communication of of what all is happening, there is no visual indicator of the thing that is the observer. It's a laser beam going up. The laser beam would be here, it would strike up, and that basically is like again, it's an EM interference. It stops the ripples from being able to form naturally. So what you end up with is just the regular where they would move to after being shot and handed through the double slit in the first place.
Go through one slit by observing it, you still get a wave interference pattern. So what's going on? Well, let me tell you the correct explanation of the double slit experiment according to quantum mechanics. So for both light and for electrons,
better be right.
There's this thing called the wave function, which I've drawn here. It's the wave associated with that object. And when the two slits are open and not observed, the wave will go through both of those slits. And
the waviness of a thing doesn't mean it is a wave. It means it, just like water, will do this wavy type thing. Water is not a wave. Water is a bunch of particles. The particles make the wave pattern. Water is a substance. When talking about the actual object, you need to please just say goes in the square hole.
Interfere with itself. But in quantum mechanics, if you ever try and observe the position of an object, it can no longer be spread out like this. So when you do this observation, it forces the electron to collapse to just one of these. And so the electron...
Again, the idea and the whole verbiage of wave function collapse is ignoring basic physical properties of, if somehow you were able to do the water experiment, make the waves, make the double slit stuff happening, and then also do a type of simulation of what a observer looks like, which is a laser going up the length of this thing across the two slits, blocking that so it doesn't make the interference pattern anymore. You'd notice the waves kind of dissipate and the water just flows out that way, straightly. as if there were no rippling nonsense going on. It's still water, it's still particles, and similarly, this also proves light and electrons are particles.
Acts like a wave, even after it's been observed. And we know that because you end up with this single slit interference, which is just impossible to explain with purely particle behavior.
Again, if water is doing that same thing, it's particle behavior. You can't be contradicting yourself like this if oh, for frick's sake.
Which is just impossible to explain with purely particle behavior. If it's
We've already done single slit waviness with water, and the fidelity of water is like extreme, and the fidelity of electrons is meant to be not as dense as water, not nearly at all. We're talking about a very tiny amount of electrons in that video in the beginning of your video, the clip that you showed.
a wave, then shouldn't we expect a big smear across this wall rather than these individual particle-like things? Well, again, our measurement rule comes into play. In quantum mechanics, you can have an object that is spread out like a wave, but when you measure the position of that object, it's forced to.
You already know that when the flow of something hits a barrier, then that ends up making it all spread out. And depending on where they started from, which is not accurate to the degree of every electron is being sent from the position of the exact same electron position, there is a slight difference. So when they get spread out, at the other end, that is amplified. The further away you are from the slit to the plate. So, if allowed to be straight on, like if there isn't like a wall covering it on one side, that would force it to go maybe downward more likely than upward, or I should say more to the left than to the right. Bear with me. If the path is going this way, then this is the right, this is the left. It all should be going into a packet there. And when you end up with two of them, yeah, you end up with two packets.
Collapse to a smaller position. So if we have an electron that goes through here, when we measure it at the wall, it has to choose where to turn up. And it's going to be more likely to turn...
It's just a dot that ended up where it ended up. It doesn't choose
up in one of these bigger regions.
She's getting an F, okay?
So are electrons waves or particles? I think that even in this case where you're measuring the electron, it clearly acts in a way that's governed by this wave function. The
Water does that. Again, electrons are particles. You cannot just have an observation. Okay, electrons are particles not just because of all of this, but because we've actually seen electrons. We know how they look like around an atom. We know that there are, like, tons of echoes around it. I've mentioned that in previous videos talking about electrons. There's a picture I could show you. So this is what we actually observe. The freaking dots, that's one electron. This whole set of dots, one electron. Okay, it says two. That's not the point. One is one up electron, one is one down electron. The fact is, these things are moving at incredible speeds. They end up looking like a blur, but they're not a blur. Their individual echoes are noticeable depending on how fast and accurate your visualing is. Camera?
It clearly acts in a way that's governed by this wave function. The wave is what determines what it does. But there is a sense in which it's particle-like, and that is because when it turns up at the wall, you find that there's always a full electron that turns up in any one spot. Like,
particles behave in wave-like ways when you have them flowing through stuff. This
electron has the same mass as that electron.
Yeah.
So the fact that they arrive as these discrete and countable and always sort of the same sized packages is what makes them particle-like. It's the fact that they can kind of be counted. And here's where it gets...
No, it's also the fact that literally in physical reality, they are particles. And electricity, the EM field goes through them. They are dipoles. They work like bar magnets. There's a lot more that we know about it. Having just the double slit experiment be the end-all be-all of what you think you understand about electrons, that's a very small amount of information, and we have other experiments. I don't know them, but we have other experiments. We have other information about electrons. So many more things. You can't. But I don't really need to go on about it. We've already talked about how water works like a fluid, makes the interference pattern anyway. So particles do this. Like the molecule of water is virtually indistinguishable from particles as they are really tiny. I mean, an atom is just not... We're not going to say an atom is a particle, but basically, size-wise and everything else, an atom is just one dot, right? But you have the water, and it's 3 different dots. For all intents and purposes, the behavior of 3 different dots is not much different than the behavior of 1. So a fluid dynamics concept is going to work on water just the same as it'll work on individual dots of stuff. So if you had a fluid that was just, I don't know, 1 molecule, it doesn't make any difference if it's water fluid or 1 molecule fluid, one atom variant fluid. Like mercury is, I believe, just itself. So there's just the mercury atom that is behaving fluid-like in all sorts of experiments. We know this. So similarly, it does fluid dynamic things. Electrons are just tinier dots compared to atoms by an order of magnitude. Photons are even tinier dots by another couple orders of magnitude, I think. So there's no reason why 1 dot in fluid dynamics would behave any differently than any other dot. And we notice, hey, they do interference patterns. That's because they're all particles doing stuff the particles do when they interact with the thing that is the wall that they're bumping against and doing a flow change. Because you got to really understand what is making water do that in the first place. And then that can help inform you about how electrons should behave in these things.
Light is exactly the same. In my previous videos about the double slit experiment with light, I got a lot of comments saying that the experiment that I was doing was just an experiment from classical optics, and all it showed is that light is a wave, which we've known for a long time.
It's a particle.
And that is all true. But I think that the quantum version of that experiment is not what people think. I got a lot of comments saying, why don't you do the single photon at a time version of this experiment? And the thing is, I would love to do that experiment, but I actually think it's going to be a little bit underwhelming. Because
the single photon experiment would require technology you can't afford.
Basically, this is how you would do it. Say that this is my source for the light. Then to do the single photon at a time version of this experiment, all I'd need to do is to turn down this light. So I've just maybe put some filters in here that block the majority of the light, so there's only a little bit going through. Now, our intuition tells us that
kind of.
If light is a particle, this thing called a photon, then surely it needs to be a particle like those little bullets that we were talking about. In that case, it would make total sense to talk about a single photon going through this experiment at a time. But that's not how light works.
Light is not observed ever as 1 photon at a time because it doesn't do that normally, because there's lots of light.
But
because there's lots of light
particles.
particles.
Light works. If I just put a filter in front of this laser, all I'm going to do is I'm going to make this wave weaker. From the side-on view, the wave would look something like this, right? And as you put more filters in front, all that will happen is that the wave will get smaller and smaller.
Can you really use filters to turn regular visible light into... I mean, we know prisms can change the spectrum of light, but I mean, would regular filters change the spectrum of light from like the visible, from yellow to red, or from whatever to whatever? That's curious.
No matter how many filters you put here, it's still a wave. At no point does it become a particle like this. And so you can see that no matter how weak these
Okay,
waves...
the problem with filters, the problem with trying to manage individual photons of light using filters is that you're still shining a bunch of light particles at stuff, and it's a lot of stuff that you really should be able to, and we can, by the way, when an electron goes from one band of orbital down to a smaller band of orbital, the light it emits is usually described as one photon. If you're able to conduct that function, you should be able to shine an individual photon somewhere, but then you'd have to be able to observe it and everything else.
That doesn't stop them from spreading out like this. And the spreading is what really causes the double slit interference pattern.
Yeah, because the electromagnetic waves from everything else is always going out in a spreading out pattern. And because both sides, as it goes through, there are two waves of EM field. That is what is guiding photons and the electrons, apparently, through to the other side. So when you mess with the EM field, with the laser beam that is the observer, you stop that interfering function, you just get straight electrons. Light is supposed to be different, but it might be just photons after all.
And so you still get the interference pattern. However, there is one really different thing about the result. Instead of getting a smear like you usually do with the double slit experiment, you're going to find that actually the light arrives in little dots, just like the electrons. But how is that possible? I said that nothing really changed when you turn down the intensity of this light. Well, the thing is, when we have this light at full brightness, there are individual dots turning up here, but we can't see them because there's so many coming per second that...
Yeah, like every nanometer is just coated with photons. Versus electrons can be maybe a couple within a nanometer.
It does just look like a smear. And it's only by turning down the light that we end up seeing these individual photons.
Or increasing your magnification on the area that you're looking at. You start seeing stuff better.
So photons are particles much like electrons are particles. They're not really. They're more waves. But a photon or an electron is more a property of what happens when they get measured. Whenever you have a quantum wave function like this.
Again, the measurement. If you're ever observing individual photons, then they still are just particles. They never were waves. The interference pattern and all that stuff is what happens when particles interact. It doesn't mean the substance itself is a wave. But that really makes an interesting quandary of the difference between like X-rays and visible light spectrum and all of that junk. Because apparently, if it's all particles, like that changes a lot. But we're, oh god.
And you try and measure the position of that object, it's forced to collapse to one particular spot.
Yeah.
After I finished recording, I found out that there's this amazing paper where they explain how you can see the individual photons of light arriving. It is from 2016, and I'll link this in the description. But here's the video.
Yeah.
So as you can see here, there are these individual photons, and it kind of looks random at first, but you can already start to see how it seems to be gathering around these fringes, which is exactly what you would expect for a double slit experiment. I'd seen this experiment with electrons before, but it was very cool to see it with photons. And as you can see, the two experiments look nearly identical. Another way that
That's because fluids work the same as each other. Wow.
Are very like electrons is that each individual photon has the same amount of energy as the other. Just like with electrons, they come in these discrete packages that are always of the same size. So for both electrons and photons, they don't really exist as particles throughout this part of the experiment.
They always do. You're delusional. I'm not gonna apologize.
They only really become particles here when they're...
No, they always were.
Measured. But then you might wonder, how can we even talk about doing this experiment one photon at a time?
This little thing helped me more than...
Here when they're measured. But then you might wonder, how can we even talk about doing this experiment one photon at a time? Well, the way that you do it is you kind of turn down this light a whole lot so that there's only a few of these photons coming, let's say, every second. And it takes much less than a second for any light to have gone from the source all the way to the wall. And so you kind of...
The speed of light being nearly 3 million meters per second, yeah, it's gonna be real fast for it to get there. Boop, it's there.
Say, well, that means that there couldn't have been more than one photon sort of going through this whole thing at a time. So that's a one photon at a time experiment. And I think that that just is bad terminology. Like, there are no photons, really, until you get to here. For both electrons and photons,
I can't believe people have this kind of delusion that there are no photons until it gets there. There is no transformation taking place. The photon's a photon throughout the entire thing. Full stop. Just like every water molecule is a water molecule throughout the entire waviness thing that we noticed in the previous video. And just like every electron is an electron, it's a particle. Here's the thing, right? People have described photons as having a certain quanta and a certain wavelength and everything. But again, if you take light and you put it through a prism, it changes its frequency. So the light, once you then spread it out, you can sort of imagine what happens with redshift must also be another delusion, because it's not redshift that's happening out in space. It's lensing. Meaning but it could also be a fluid dynamics thing where if you consider all of light as the collection of photons in, say, a cubic tiny space, I don't want to say because it's not going to be great, but let's say nanometer. right? You take that light packet of a cubic nanometer, it's a lot of photons in there. Over time, based on where their source was, each one of them could have a trajectory that is slightly askew compared to normal straight. And so over time, they might spread out and redshift, but it's not redshifting that's happening. It's just that they literally came from slight askew compared to straight as its neighbor. So over a great distance, we're talking about entire quadrants of space. Over a whole gap between like the billions of light years or all the way to quadrillions of light years. I forget what the number was someone said redshift works. But it could simply be that they are extremely accurate and straight and with each other. But what happens over distances is those, and it's a crazy distance, which is so much different than the distance and attenuation of a laser beam. Light from a sun, yeah, the only reason why we're able to see that in packets is that a lot of them kept going a straight line towards us, right? There's still a lot more light that's out there. It's just heading in other directions, like it's heading higher up or it's heading on the other side of the planet and all the way around, right? There's still light coming from that star going in all directions. But the interesting thing is that the intensity of the light or the type of attenuation, I think redshift is just something that happens when light has been able to travel long enough and has nothing to do with the expanding universe. That's another misobservation. I'm 100% certain that the universe is not expanding, but stuff is spreading out, moving in its own regular directions, as long as they're not being affected by another local galaxy or something nearby. Stuff just ends up shooting off in the same direction with the same velocity forever. There's nothing else to stop it except for the subquantum, like static foam of the very below photons level, the EM field itself. The problem is people get caught up with the idea of it being a wave when it's really just a bunch of particles with a certain interaction. The only reason why we even see colors in the first place is because different ones bounced off at different rates and we end up seeing those different colors. It's all a base of texture, not what we actually are seeing is still just a photon behaving with a signature of the textures that the entire group of photons, like, I don't think you can get a single photon that will only be, for example, yellow, or a single photon that will only be, for example, green, or whatever, or blue, or anything like that. I think you're only going to end up with photons that collectively, because of how they interacted with the world, you end up, well, here's the thing. Again, I go back to, I have to correct myself. We talked about the shell of the electron And depending on the size difference of that photon emission, that's the light that we end up seeing. That it changes its exact, so like helium and hydrogen and all the different particles, all the different atoms have their own electron shell displacement based light spectrum that they fall in on, and they will always make that color light depending on the shell size that they changed with. And it's fascinating to see something like that. But then it does beg some questions, but still, photons are just particles. They work in wave-like behaviors, yeah, but they're still just particles.
Imagine these as sort of individual balls coming out of the source. And that's what's the source of the confusion, because we think that a single particle can't go through two slits at the same time.
It doesn't.
But there is no contradiction when you see that both of them.
You see, the photons and the electrons, they're still interacting with electromagnetic field. It's still you're not referencing the electromagnetic field itself. You're thinking only of particles. You're thinking only of photons and electrons. You're not thinking of the EM field. You get an F. Or at best, a D. Not mine.
Are actually just waves. And waves absolutely can go through both slits at the same time.
Exactly, they can.
They really only become particles when they're measured at the wall. That's why
Listen, the waves go through both slits at the same time. The particles don't. The particles simply go through one slit and land somewhere, and we can know exactly how that all traced out. We know exactly how it all traced out. If you have detectors on either slit going vertical in the same direction as the verticality of the slits, then you can tell, did it go through this slit or did it go through this slit? And yes, you will be interfering with the propagation of the interference pattern, but you'll still get the individual, did the electron ever go through both slits? And you'll know. Fascinating results, though.
that experiments with light are still very interesting quantum mechanically, because we know from the maths of quantum mechanics that light and electrons behave almost identically. Like in my last video where I did the quantum eraser experiment with light, and it was very easy and it just involved polarizers, a lot of people pointed out that you can totally explain this just using the regular polarization of light in classical optics. But
yeah.
Did you know that you could do that exact same experiment again using the spin of the electrons? The maths is the same. So the real lesson from the double slit experiment is that both electrons, which we think of as particles, and light, which we think of as waves, act identically. And that's a profound result because it means that both of them are kind of neither particles or waves exactly.
Oh, frick you, man. You have to leave off with the it's a this or it's a... No. Again. It's silly to make the argument that we don't... Like, you're trying to figure out if it's a particle or a wave with only the double slit experiment to be the example, and your control is water, and yet you come off with maybe they're waves. Water is particles. Essentially. Packets of bits of water are basically molecules, whatever else. It's still, again, a fluid dynamic. So yeah, photons would work with a fluid dynamic way, and electrons would work with a fluid dynamic way because they are particles. knowing that the interference pattern happens with any fluids, it makes sense that you would find the interference pattern type stuff with the smaller stuff. It would still be particles, physically. The thing that really... the problem is thinking about photons as particles, which I always thought was the understood thing. However, the waviness of light and the wave spectrum of how light works is like... Veritasium did a video on the optics and such of how light interacts with clouds to make rainbows. And the rainbow that one person sees is not the same rainbow someone else sees, who's right next to them. Because the light is a different stream of particles that had their own interactions with the refractive and prism type properties of the rain droplets in water, in the clouds, or whatever other thing that makes rainbows from water and light. So, again, that being said, it's still a bit different to change its frequency. Like, the visible spectrum is one thing, but it's interesting to think that you could change the entire frequency. Something as simple as, like, if you use a prism, can you actually still use a kind of prism that can change invisible light spectrums into visible light spectrums? That's a whole other topic, a whole other thing. I just thought of it. Give me the credit for that. Actually, no, because there was a guy ages ago who made experiments, and those experiments are quoted in, I think it's Phenomenon, the John Travolta movie, where there was this whole thing about using regular light and using it with some optics to make the UV light that plants need, or whatever. UV lamps are easily made. I mean, there's no reason why. We already know about grow lamps. That's a thing we can do. Light is particles. Electrons are particles. There's wave-like properties in that. The structure and everything else is still, like, for some reason, like the absolute structure of an electron. I don't remember seeing a video that showed the actual absolute structure of an electron. And that has to do with that whole, there's going to be experiments done with femtosecond type frequency shifting. So they're changing the spectrum of light every interval so that it's overlapping, and the gaps and everything. We'll be able to visually know what electrons are like with extreme fidelity. Better than we've ever been able to see in any of the pictures I've shown you thus far, or experiments that we've been able to do thus far. Again, the electron experiments that happen, those aren't electrons that we're seeing hit those detectors. That is an electron hitting a substance that makes a reaction that shows us when the electron hit. It's not us actually seeing, like, the actual size of an electron and all of that. we're seeing something that's way blown up, so it can actually be visibly, like on a camera, seen. The actual electron is many times smaller than that. It's like 10 to the 15th versus an atom is 10 to the 11th. Minus meters. I'm tired of it. I want people to realize how all of this works. There's a lot of comments. I have not been watching. Okay, how are you doing today, Mr. Commenter? What the hell? SOD. Sid. Double slit experiment has been misinterpreted for over 200 years. The whole concept of light as waves is nothing more than mathematically elegant. Fucking yeah. That lady is completely clueless. Not completely, but like sort of. Amazing how she doesn't see it light reflect in multiple. I'm sorry that I didn't have chat on. I wanted to do things differently, whatever. Single reflection off the edge of the slits. Ask yourself why light makes sense to be fringe pattern with a single slit and why, while water is not. Water is. What are you talking about? So why not light? Interference is therefore with a single wave. Interference is therefore impossible. So why light? Light is high fidelity. Like water. Again, electrons are way smaller than atoms. Water is a collection of atoms, known as a molecule, 3 of them. And then photons are way smaller than electrons. So, you can understand the difference between where each photon comes from and how they spread out once they hit that wall and do that wave type single slit experiment stuff. They're going to spread out, they're going to do stuff like that and whatever else. It's so simple. Everybody ignores the damn edges. Yeah. Too bad you're not reading this. Complete fantasy, there is no light waves. Yeah. Hi. Hi, Chloe. Superposition does not exist. Pure fantasy. Well, here's the thing. Again, electrons are moving so fast, it's about a quadrillion orbits around an atom every second. Extreme number like that. So imagine you have a quadrillion of anything orbiting around a very small space. You're gonna end up with what seems like a blur. There is no EM field and particles. Excuse me, buddy. There is so an EM field. There's an interaction between electrons and protons. That is the EM field doing a thing. That is the connection between electrons and literally everything else in the universe. It's why it's also... Oh, frick. Moving aside, light is the field itself. Light is just the EM field, then why is it also particles? J.J. Thomson's cathode ray tube experiment shows a straight beam where lighted electron, where you're seeing electron beads They were only infrared. It is continuous ray of the medium. The lady physicist is clueless. Wow, she just admitted his about the edge. His, but she doesn't get it. Yeah, I know. Yes, say it. Reflection. Uh-huh. Teenager is complete mad. As a quantum mechanism, all cause the clinging to the stupid wave. Yeah, it is kind of... Well, the thing is, there's waviness, but it's still just an act of particles, just like water and whatever. Quantum mechanics is the ultimate example of forcing a square peg into a round hole. That's why I said square hole! You think I said square hole randomly, and then you said it. Is it coinciding? I don't know. I'm not going to say. Whole framework was built on foundational fallacy. Like, the whole assumption of how things work is ridiculous. Relativity is a lie. That for some reason you can have something be simultaneous, but also in a different... going at a different speed. You notice them happening at different times. You notice that light get to you at different times, or the sound get to you at different times. That's a Doppler effect. But that doesn't mean that the actual events happen at different times versus if you're standing right there. It's just, relativity was stupid. Particle behavior is a reflection, single reflection. It's not reflection, it's refraction. Refraction. Stupid wave function is mathematical probability. Wave is not real. For fuck's sakes. No, the wave function is, again, we saw water do the interference pattern. It's just a fluid dynamic thing. It's not probability. You can know where the electrons, water molecules, or whatever is going to end up based off of accurate testing, which no one has done. Okay, if you're not going to read this, I'm out of here. Good luck. Well, I read it. And if you saw the video, you would know I read it. So there. Bitch. No. The interference pattern is literally a physical thing. We saw it with water. It's not mathematical. It happens. It's the physical phenomena of what happens with any fluid. Meaning, light, electrons, they're both particles. There are wave-like behaviors. The substance is still a particle. And that's the end of the video, basically. I don't know why I decided to change the size of the whatever. So here's the thing, right? We just saw those two things. Quantum computing hype, the double slit stuff, and whatever. Problem with groundbreaking quantum experiment. Dude, people literally thought that there's quantum entanglement. That's also a lie, because there is no actual physical interaction happening between the two distant particles. There's just literally, they manufacture the way that the light splits. I think it was a calcium atom or something. So it directly splits in half. One half goes this way, one half goes that way. And then you're wondering if there's a correlation with the two. It's like taking two halves of a baseball and then measuring that. It's like maybe it was up, maybe it was down. That's about the orientation of the baseball when it lands. As it goes through the air, it's doing all sorts of stuff. But it was still a baseball you cut in half. And when you get that, you know that there is no such thing as quantum entanglement. Unfortunately. If quantum entanglement did exist, and if the space-time curvature existed, then we would know that there is the ability to possibly be able to have a space-time curvature warping so great that it can go back in time or forward in time faster than normal speed of everything. If you're able to go forward faster or backwards in time because of space-time curvature nonsense, which is complete falsehoods, you would be able to send a signal with that quantum entangled particle to the future. It can react, and then it would react and interact with the past particle, and then it would do its thing. Quantum entanglement is a hoax. The Nobel Prize was given because people are idiots. They didn't have me on the committee. I would not have given them the Nobel Prize for their experiment because it was a bunch of nonsense. But that's the thing. You have like freaking... So, wait, I'm saying I'm smarter than freaking NASA or whoever the hell was on that committee. Yes. I'm not saying they don't get a lot of stuff done. I'm just saying there are some things that they'll just skimp on, and it's stuff that's so niche. There's so much information, and here I am getting cliff notes of cliff notes, and I'm still getting better intuition about how it actually functions than what they've been combing over for the past long time, because it's a lot of information to pass through their heads. It's easy to get things wrong when you haven't like taken a lot of time to analyze it like I have. I've spent over a decade analyzing this stuff. I've made similar videos pretty much every given month talking about electrons, quantum mechanics, relativity. I don't know why people perpetuate it. Why people keep on saying relativity is a thing. Why time dilation is said to be a thing. It's a phenomenon that's hard to explain, technically, for everyone else who hasn't gone through the rigor of it. But I've already explained it a bunch of times in my videos. Over and over and over. I'm sorry that I didn't have chat open, but I did read chat. You got a couple of things wrong, like there is an EM field. There has to be. There's no reason why anyone would say there's just electrons, and then there's also like no connective tissue of the EM field connecting them to protons. And then go one step further, you realize the EM field is also the dark matter we've been looking for the whole time. It's the thing that's connecting Pluto to the sun. And that's not even a weak connection. You realize we're going at speed around a galaxy. We're holding ourselves together in our solar system because of literal magnetism at a distance. But it's not calculated or seen as like proper electromagnetism, because it's not about the interaction of electrons and the EM field. It's about the interaction of the entire substance mass and the electromagnetic field. That's the thing. Electrons and photons does not an EM field make. The EM field is something smaller than even photons. Or it might be photon. I heard some people say that the photons are the thing that is being shared in. It's like you have electrons, they're flowing photons through themselves and everything. But still, there's this governing force there, a guiding thing, and it still feels like there's this EM field that is, again, I am 100% certain it is smaller than photons. Look, water is a fluid doing interference pattern. Light and particles also do fluid things because that's what they are. You get a D for missing it so mostly completely. I responded, good day, glad we keep learning. That's my comment on your video. You have, if I were marking your essay, I would say you get a D. Not a complete failure. You recognize some components of things. You completely miss other components. And again, you don't talk about the electromagnetic field, which is not electrons. It's a different thing. It's a completely separate thing. The electrons and the electromagnetic field, again, Veritasium did a video talking about electromagnetic waves that are the thing that really does the transmission of energy across electricity wires. It's not the electrons themselves moving that fast. The waves of energy are doing that. And that's the EM field. That's what's happening. So you have to understand that. You have to put EM field in your vocabulary, start using it, start understanding it. It's just how things are. So, knowing that, you have to also understand it's the EM field that makes the pattern. Or it's also the fact that electrons or photons are genuinely particles like a fluid. Or it's the EM field, really, that makes the fluid dynamics. And the particles are just along for the ride. Just like with any. This is what happens when you shoot individual electrons, because the EM field is doing the fluid dynamics. It's not the particles, because they're shot individually, one at a time, one after another, in quick succession maybe, but not fast enough that the fluid dynamics should be how you describe the motion of electrons in that video we saw in the beginning of it. Let me show you again. This is the video.